Welcome to GATE video. This is Sreevani. I am working as an assistant professor in S.A. Engineering College, Department of Computer Science and Engineering. Today I am going to take a GATE lecture on tree traversal. First we will see what is meant by tree traversal. Tree traversal, it is nothing but you are going to visit each node exactly once in a tree. So they have categorized this tree traversal into two types: depth first traversal and then breadth first traversal. First we will move on to the depth first traversal. It is also known as DFS. This breadth first traversal consists of three techniques. First one is a pre-order traversal, in-order traversal and then post-order traversal. So first we will move on to the pre-order traversal. In pre-order traversal, you are going to visit first root node, then left node, then right node. We will see one example for pre-order. So before you are going to solve the problem, first you need to write the formula for the pre-order. The formula for the pre-order traversal is first root, then left, then right. So in this tree, what is root? A is root, and then left for A is B. Again it's a subtree. For this subtree, what is root? B is your root, and the left is D, and right is E. So for A, the left is completed, then move on to the right side. If you see here means again it's a subtree. For this subtree, what is root? C is your root. For C, what is left? F. And for C, what is right? G. This is the pre-order traversal. Next, we will see the in-order traversal. In in-order traversal, first you are going to visit left node, then root, then right. So we will see one example how to solve the in-order traversal. First, you have to write the formula for in-order. Formula for in-order is left, root, and then right. For A, the left is B. Again it's a subtree. For B, the left is D, and root is B, and right is E. So left is completed and root is A. Then move on to the right. Again it's a subtree. So for this subtree, the left is F, and root is C, and right is G. This is in-order traversal. Next is post-order traversal. In post-order traversal, first you are going to visit the left node, then right, and then root node. We will see the example for post-order. First write the formula for post-order: left, right, root. So first left. For A, the left is B. Again it's a subtree. For B, what is left? D. What is right? E. The root is B. Left part is completed. Then move to the right side. Again it's a subtree. For this subtree, what is left? F. What is right? G, and root is C. Now you have completed the left part and right part. The root is what? A. So this is a post-order traversal. The next one is depth first traversal. In depth first traversal, you are going to visit the nodes level by level. So they have kept the another name for DFS is level order traversal. So we will see one example. This is the graph. For this graph, you need to calculate the level order traversal. First you need to write the levels. So this is level 0, this is level 1, This is level 2. First you need to visit all the nodes presented in the level 0. So in level 0 you are having only one node, that is A. Then you have to move on to the next level. In level 1 you are having 2 nodes. You have to visit the nodes from left to right, that is B and C. Then move on to the next level, that is level 2. In level 2 you are having the nodes D, E, F and G. So all nodes you have to visit from left to right, D, E, F and G. This is depth first traversal. So we will solve some problems they have asked in the gate. Suppose the numbers 7, 5, 1, 8, 3, 6, 0, 9, 4, 2 are inserted in that order into an initially empty binary search tree. The binary search tree uses the usual ordering on the natural numbers. What is the in order traversal sequence of the resultant tree? So first you need to construct the binary search tree. First you need to construct the binary search tree. So before you are going to construct the binary search tree, first you need to know the property of the binary search tree. In binary search tree, the leftmost elements all are lesser than the root node and the rightmost elements all are greater than the root node. Based upon these two properties, now you are going to construct the binary search tree. So first is what? 7. Next one is 5. 5 you compare with 7, which is lesser, so insert the left side. Then 1 compare with 7, 1 is lesser than 7. Then compare with 5, 1 is lesser than 5. Then insert the left side. Take next element, that is 8. 8 you have to compare with 7, which is greater, so insert at the right side. Next one is 3, compare with 7, which is lesser. Compare with 5, which is lesser. Compare with 1, which is greater, so insert at the right side to the 1. Next element is 6. Again you have to compare 6 with 7, so which is lesser. Then compare with 5, which is greater, insert at the right side. The next element is 0. Compare 0 with 7, it is lesser. Then compare with 5, which is lesser. Then compare with 1, which is lesser, so insert at the left side. Next element is what? 9. Compare 9 with 7, which is greater, move on to the right side. Compare with 8, 9 is greater than the 8, insert at the right side. Next element is what? 4. Compare 4 with 7, which is lesser. Compare with 5, which is lesser. Compare with 1, which is greater. Then compare with 3, which is greater, so insert at the right side 3. Next element is 2. Same procedure. Compare with 7, which is lesser. Compare with 5, which is lesser. Compare with 2, which is greater. Then compare with 3, which is lesser. Though insert at the left side for 3. Now we have constructed the binary search tree. Now you have to calculate the in order for this one. So first you need to write the formula for the in order. What is the formula for in order? Left, root and then right. So apply the formula for the given. What is left for 7? 5. Again it's a subtree. So for 5 what is left? 1. Again it's a subtree. So what for 1 what is left? 0. So first write 0. Next is what? Root. For 0 what is root? 1. Next is what? Right. For right what is 3? Again it's a subtree. For this subtree what is left? Left is 2 and root is what? 3 and right is what? 4. So now left completed, root completed, right completed. This is left part for 5. So the root is what? 5 and then right is what? 6. Now the left part is completed for 7. What is root here? 7. Then move on to the right side. For this right side, so again it's look like a subtree. For this subtree there is no left. So what is root here? 8. So what is right here? 9. So the answer is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the answer is C. So another shortcut is for in order is whenever they will ask in order, so your elements should be in the sorting order, which means that in ascending order. So if you observe here means, so the elements all are arranged in the ascending order. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can write it directly also by using this shortcut. So we will move to the next one. So here they have given the pre-order traversal. From this you need to calculate the post-order traversal. First you need to construct the tree. First take 15, then next 10 compare with 15 which is lesser. So insert at left side, then 12 compare with 15, so which is lesser, compare with 10 which is greater, then insert at right side. 11, next element is 11, compare with 15, so which is lesser, compare with 10 which is greater, compare with 12 which is lesser, insert at left side. Next element is what? 20, compare with 40, so which is greater, so insert at right side. Next element is what? 18, compare 18 with 15 which is greater, compare with 20 which is lesser, insert at left side. Next one is what? 16, compare 16 with 15 which is greater, compare with 20 which is lesser, compare with 18 which is lesser, then insert the left side. The last element is 19. 19 you have to compare with 15, so which is greater, compare with 20 which is lesser, compare with 18 which is greater, so insert at the right side. From this one you need to calculate the post order. So first you need to write the formula for the post order. The formula is what? Left, right and then root. Okay, first you see for 15 what is left? So 10. So the 10 it's again a subtree. For 10 what is left? There is no left. Then move on to the right. What is right? 12. So 12 again it's a subtree. For this subtree what is left? 11. What is right? There is no right. So what is root? 12. So for 10 left is completed, right is completed, then root is what? 10. So for 15 the left part is over, then move on to the right part. The right part is 20. Again the 20 it's a subtree. For this subtree what is left? 18. So 18 again it's a subtree. So for 18 what is left? 16. What is right? 19. What is root? 18. So for 20 the left part is over. Then what next? Right. There is no right part. What is root? 20. Then here the left part is over and right part is over. What is root? 15. The answer is 11, 12, 10, 16, 19, 18, 20, 15. The answer is B. Next one, a binary search tree is generated by inserting in order the following integers 15, 50, 15, 62, 5, 20, 58, 91, 3, 8, 37, 60, 24. The number of nodes in the left subtree and right subtree of the root respectively is. First you need to construct the binary search tree, then you need to calculate the number of nodes presented in the left subtree and the number of nodes presented in the right subtree you need to calculate. Okay, first we need to construct the binary search tree. The first element is what? 50. Compare 50 with 15, lesser, left side you have to insert. 62, so which is greater, insert at the right side. Take 5, compare with 50, lesser, compare with 15, which is lesser, insert at the left side. Take 20, compare with the 50, which is lesser, compare with 15, which is greater, insert at the right side. Next one is 58, compare 58 with 50, which is greater, then move on to the right side, compare 58 with 62, which is lesser, insert at the left side. Then 91 which is greater than 50, 91 is greater than 62, so insert at the right side. Take 3, which is lesser than 50, which is lesser than the 15, which is lesser than the 5, so insert at the left side. Next one is 8, compare with 50, which is lesser, compare with 15, which is lesser, compare with 5, which is greater, so insert at the right side. Next 37, compare with 50, lesser, compare with 15, which is greater, compare with 20, which is greater, so 37. Next 60, compare with 50, so which is greater, compare with 62, which is lesser, compare with 58, so which is greater, then move to the right side. Next one is 24, compare with 50, so which is lesser, compare with 15, which is greater, compare with 20, which is greater, compare with 37, so which is lesser. Now we have constructed the binary search tree. From this one, how many left nodes and how many right nodes are there you need to calculate. Count how many left nodes are there. 1, 2, 3, 4, 5, 6, 7. Count from right side. 1, 2, 3, 4. So the left is 7 and right is 4. The answer is 7, 4. Thank you. We will continue on the next session.